Hi, welcome to this lecture on mathematical methods for biologists. We have been learning various techniques to learn integration, and in this lecture we will learn one more important part of integration, which is we will essentially do more examples and we will learn how to integrate product of two functions. So if you have product of two functions u and v, how do we do the integral? So to understand this, we have to just quickly think about how did we do derivative of product of two parts. If we know that, how did we find the derivative of product of two functions? If we understand that, we can easily find and easily use it to find the integral. So let us start thinking what we did. So we had this function f, which was product of two functions u and v. You have two functions u of x and v of x. For example, this might be x and this could be e power kx. We had product of two functions, and how did we find df by dx? We said that this is nothing but keep the first this constant and find dv by dx plus keep this constant du by dx. This all one has to know. Once you know this, one can easily find out how to integrate, how do we think about integrating a function which is a product. So let us think about it. So what we have here is df by dx is equal to u dv by dx plus v du by dx. So let us rewrite this once more here. We have f is equal to uv and we have df by dx is equal to u dv by dx plus v du by dx. I can integrate this everywhere multiplying with dx. So I can, let us say I want to find the integral of this. Is the same as the integral of this plus integral of this. So I can, different terms I integrate, and we know that integral of this would be f, because df by dx integral would be f. And let us say we want to find the integral a to b, some limit a to b. So whenever, always physical problems will have appropriate limits. So we will look at this example with a limit. So a to b v du by dx, here a to b u dv by dx, a to b df by dx. So these are the terms and this we know. Now to calculate this, right, how do we, if I want to calculate this, if I want to just calculate this, integral of u dv by dx dx, I can take everything to this side and write integral of u dv by dx dx is equal to this integral, which is integral df by dx dx minus this term. I take this term to the left hand side, which will turn out to be v du by dx dx, and I can put a to b, a to b, a to b. This is an important formula, and this can be used to calculate integral of product of two functions. If you have two functions u and dv by dx, these are the two functions, then I can calculate the product of these two functions by using this formula. Let us understand this formula a little bit more. So what we have here is the following. Let me rewrite this here. So what we have? We have integral u dv by dx, u dv by dx is equal to integral a to b df by dx minus integral a to b v du by dx. This is what we have. Now let us think about this a minute. So we want to calculate integral u dv by dx. So let us write that way. Integral a to b u dv by dx is equal to, you have a derivative df by dx and we know that its integral is going to be f. So this is going to be f, right, which is basically the function that we want in the limit a to b. This is f in the limit a to b minus v integral du by dx a to b. We could calculate this way that this integral u dv by dx is going to be this function f. Now what is f? F is uv, because we started with function as uv, so f is nothing but uv. So because we started with uv and found df by dx is u dv by dx plus v du by dx. So our f, the function is uv. So this is, we didn't do anything, we just started with f is equal to uv and calculate df by dx and wrote this, and except this term, everything, all other terms we took to one side, and we got that u dv by dx is equal to df by dx integral minus v du by dx integral. So that's what we got. So this would, in other words, this is an important formula that one you would use to compute integral, which is integral of a product of u and another function dv by dx, which is the derivative of some function v. Integral of this a to b is equal to the uv itself in the limit a to b minus integral v du by dx a to b. So this is an important formula idea that one would use very often to calculate integral of product of two functions. Now why are we doing integral of product of two functions? Many a times in biology and many examples we would want to have product of two functions. For example, like we will see that when we want to calculate the mean, the average of a distribution, we would have to calculate x times p of x dx. So we would immediately see that when we want to calculate mean, standard deviation, etc., we would want to do such integrals where we have two functions in these products. When we want to do Fourier transform, some technique that we would learn, we would want to use this. So it is important very often to calculate this whenever you would have product of two functions. So for example, I could start, if you want to calculate x e power minus kx dx. If we want to calculate, we would use this idea where we would consider x as u and e power minus kx as dv by dx. So by taking u as x and dv by dx as e power minus kx, x as u and e power minus kx as dv by dx, we can do this integral using this formula. So let us see how do we do this and what is the answer that we would get. So let us calculate this particular integral, which is integral, let us say, it turns out that we want to calculate integral 0 to infinity x e power minus kx dx. It turns out, later you will realize that this is also will be the mean x for a function with exponential distribution. If you have a exponential distribution, something x is exponentially distributed, you have a distribution which is e power minus kx, then we would calculate integrals like this, and that would be very useful to do that. If I normalize it, I need to have a normalization constant a here, and if I do this, this would turn out to be the x average if I have a normalization constant here, which will turn out to be k itself. Okay, so before doing this, let us try and understand, doesn't matter whatever be this answer I, if you want to calculate the answer to this integral, let us do this integral and see the answer. So we would take this as u and this as dv by dx. And we said that integral u dv by dx is uv in the limit a to b minus integral v du in the limit a to b. That's what we have said. So now let us see what is u. So this is u is x and dv by dx is e power minus kx. So this would mean that the first term, which is x, u itself, what is v? V is nothing but if dv by dx is equal to e power minus kx. So what are we saying? We are saying dv by dx is e power minus kx. So v is integral of this, which is e power minus kx divided by minus k. That is my v. If dv by dx is e power minus kx, v is integral of this, which is e power minus kx divided by k. So x times e power minus kx divided by k minus, this is the limit 0 to infinity, minus v, which is e power minus kx divided by minus k, this is minus k here, du by dx, which is 1, dx 0 to infinity. If I do this, I would get the answer. So let me redo this a little bit more properly. So what do I want? I want integral x e power minus kx dx 0 to infinity. What we know is that we know that dv by dx is e power minus kx. So integral of this v would be e power minus kx divided by minus k. That is my v. And the integral of this is integral uv. So integral, this is u dv by dx. Dx is uv in the limit minus v du by dx dx. Integral limit here is 0 to infinity, 0 to infinity, 0 to infinity. These are the limits that we have. This is the formula that we want. So let us apply this formula. So the integral is equal to u times v, which is x times e power minus kx divided by minus k, 0 to infinity, minus v, which is e power minus kx divided by minus k, integral 0 to infinity du, which is u is 1, so u is x, so du is 1, so that is dx, du is derivative, du by dx is 1, dx by dx is 1 and dx. So this will be the answer. If I do this, I would get the answer. And we know that if I apply the limit, if I substitute wherever x infinity, I can substitute e power minus infinity and this will turn out to be 0. So since one can apply L Hospital's rule or L'Hopital rule and then see that this answer to this is indeed 0. So if I do this, you would get the upper limit. If I apply e power minus infinity is 0, therefore this would turn out to be 0. And if I apply 0 here, e power 0 is 1, but this is 0, so this will turn out to be 0. So this whole term, this whole thing will turn out to be 0. So 0 minus k, so this will give you plus, and e power minus kx by k would be the answer. So let us redo this. So let us do this a little bit more carefully below. So the first term, so look at here. So the first term will give us 0. What will a second term give? So let us see that. So the first term from here would give us 0 minus, and there is a minus k here. So this is plus 1 by k. I take this k outside, and integral 0 to infinity e power minus kx dx. So 1 by k e power minus kx 0 to infinity e power minus kx dx. And we know that 1 by k e power minus kx dx is e power minus kx by minus k 0 to infinity. And this will turn out to be 1 by k as it is, e power minus infinity is 0, so 0 minus 1 by k, and this would turn out to be 1 by k square. So 1 by k times 1 by k, and the answer is 1 by k square. So if I do this integration by parts carefully, integral 0 to infinity x e power minus kx dx, if I do this, I would get the answer as 1 by k square. And the x bar, we would learn this, you might have learned, those who have learned statistics, the mean for a exponential distribution is basically going to be k itself, and this is because here the p of x has k e power minus kx. This is the formula for the probability distribution for an exponential distribution, and then if I have a k here to multiply, the answer would be this. So that is, if this is my p of x, if I do integral p of x dx 0 to infinity, and this would turn out to be answer as k. So do this, take p of x as k e power minus kx, and do this x p of x dx integral 0 to infinity, you would get k as the answer, which is 1 by k square times k, and you would get the answer as k. So I urge you to do this, and this would give us this answer using this product of two functions. So you could use many times, whenever you have two functions, you would want to use one as the derivative and the other as this kind of function. For example, you would have many functions where, for example, let us see other examples like minus infinity to infinity, some function u dv by dx, you would want to do this dx, you would get uv minus infinity to infinity minus integral v du by dx dx, minus infinity to infinity. So many a times we would want to use these functions, and there will be many examples whenever exponential functions comes, or you could have sin x, cos x, you could even have like functions like sin x e power minus kx, or you could have x cos x. Doesn't matter, you would have many functions where you would get the product of two functions, and you would want to integrate this, one would use this product rule and one would calculate this integral. These are examples of integrating product of two functions. This would be applicable whenever we have typically two kinds of functions. And so this is called integration by parts. So this is often called integration by parts. Very often you would have, books would describe formulas like this, u dv. What do they mean is u dv by dx is equal to uv in the limits minus integral v du. This is very often very highly useful formula which one would use at many places. Whenever you have two types of x and sin x, e power x and sin x, a trigonometric function with the product of an algebraic function, or whatever log x times something. So whenever you have two types of functions and you have a product of two functions, we would want to use this kind of formula, and it needs a lot of practice to figure out which one to take u and which one to take dv by dx, and how do we actually calculate this integral. And we would, if you want to calculate the same thing numerically, we would basically would want to plot that function and calculate the integral. For example, let us say we would want to calculate integral of a to b x e power minus kx square dx. So if you want to calculate this numerically, what we would want to do is basically to plot this. So if you plot x e power minus kx square, so e power minus kx square is a decreasing function. It's a symmetric function, so like a normal distribution function, and x is, so e power minus kx square is a function which is like a normal distribution. So nice symmetric function like this. I didn't plot it very symmetrically, but this is a symmetric function, it's like a normal distribution function, and x is a function like this. And if I find the product of this would be positive and this would be negative. So there will be a negative part. Product of this times a negative number times a positive number will be a negative number, while positive times positive will remain a positive. So this will have a positive part and negative part. And it turns out that if I plot x e power minus kx square, I would get a x part here and a dying part like this, something like this, but nicely symmetric, roughly like this. You would get some function like this. This is my x e power minus kx square function. Function x e power minus kx square would look like this. Now once you have such a function, we could calculate the area just like we did. We could divide this into small boxes and find the area appropriately, and this is boxes, and find the area here. And we know that if since it looks, this is a symmetric function, so that is, if I have, there is a symmetry here in the sense that the positive part and the negative part looks exactly symmetric. In other words, it's an odd function. This is f of minus x would be minus f of x. This is x, we saw that, and then this would have, the area under this will turn out to be 0, because if you have positive part and negative part, and you would sum them and you would get this area. And one could get area of this curve by doing this. You could think of many functions which are product of two functions, like you would have an x square e power minus kx square. You could, let us take this function x square e power minus kx square. So let us take our function x square e power minus kx square. This is not an odd function, but it's an even function, interestingly. That is, f of x so there is a x square, sorry. The function is x square e power minus kx square. That's my function. If I take this function is actually an even function. What does that mean? F of x is f of minus x. In other words, x square e power minus kx square is equal to, wherever x I put a minus x, e power minus k minus x. Instead of x, wherever x, I substituted a minus x. Here there is an x, so I substituted a minus x. These two are exactly equal because minus x square is x square minus k, this minus x square is x square. So these two are same. So this is an even function. So this integral would be a positive number itself. It will not be a 0. And the good part is that one can do this in different ways, and one could plot this function. So numerically doing is plot this x square e power minus kx square and do this using the formula that we learned. That is a method to do this. So what we learned so far is how do we find, whenever you have product of two functions, how do we find the integral of this is what we learned. And the product of two function, we learned the important formula which I would want to summarize, which is basically that integral limit a to b u dv by dx. So I have a function u and another function which is derivative of some function v dx. This is nothing but u times v in the limit a to b minus integral v du by dx a to b. So this is the formula, this is something we would apply very often to understand, to do these integrals, and we will see this is useful at many points, in many cases, and we will learn this as we go along. With this, I will stop this lecture. Bye.